Hi everybody, welcome to Unit 4, Video 2. And so if you do not have your Unit 4 notes out, please go get them now. All right, so we are on Roman numeral 3. I can simplify rational algebraic expressions. So when you're simplifying these expressions, what you want to think about is there's really like an invisible set of parentheses around this expression here. Because remember, these two are connected by this negative sign, this operation. So you don't want to just go straight to simplifying this 8x squared to the 4x squared because you really have to apply the denominator to both of them. So what we have to do here is we're going to factor out the greatest common factor, which in this case on the numerator is a 2x. So you're going to factor out a 2x, and so when you do that, you're left with 4x minus 3 over 4x squared. So now that you've factored out the greatest common factor, now you can go ahead and simplify what you have here. You can simplify 2x and 4x squared. So when you do that, you're going to be left with 4x minus 3 on the top, and these two are going to reduce to 2x. So then that is the only thing that can reduce because this, remember, is in a parentheses. It's an expression, it's connected. All right, so let's go ahead and look at number 2. So again, you want to remember that your expressions here, this trinomial on top, it's like bounded by an invisible set of parentheses, and so is your expression here in the denominator. So you want to go ahead and I would put the parentheses so that you know they're together. So then remember, our first rule of factoring is we factor out a GCF. So in this case here, there is one. On the top, the numerator is x. So when I factor out that x, I'm left with x squared plus 6x plus 9 over, okay, and then on the bottom here, the GCF we have here is also x. So I'm going to factor that x out, and I'm left with x squared minus 9. So at this point, if you can simplify, you want to. And so right now, these two x's that I factored out, they can cancel. But if you take a look at this trinomial, and the expression that you have on the bottom, both of those are factorable again. So you want to factor again. So when you do that, on the top, you're going to get x plus 3 and x plus 3. On the bottom, x squared minus 9, that's factorable. It's a difference of squares. You're left with x minus 3 and x plus 3. So now that you have this, you want to simplify if you can. And since you have an x plus 3 on the top, it can cancel out with the 1x3 on the bottom. It's 1 for 1. So even though there's 2 of them and there's 1 on the bottom, you can only get rid of 1 for 1, okay? So now that you have this, your final answer is going to be x plus 3 over x minus 3. And remember, these are expressions. They're bounded by parentheses, so you can't just cross out the x right here. They have this invisible set of parentheses. Okay, so next problem. What you want to do is you want to simplify what you can. And remember, when you have y minus 2 squared, the quantity squared, you want to write it out twice. So this is y minus 2 times y minus 2. Sorry about the pen. All right. So on the bottom, y squared minus 4. This is factorable. This is a difference of squares. So you have y minus 2 times y plus 2. So now that you have this, again, you want to simplify if you can. So this y minus 2 on top is going to simplify with the y minus 2 on the bottom. So what you're left with is y minus 2 over y plus 2. All right. Okay, so what we need to do is make the negative exponent positive. And to do that, we would take the reciprocal. So you can think of it like this. You have the trinomial on top, x squared plus x minus 6. And this is saying when you flip this times 1 over x plus 3 squared. The quantity x is 3 squared. So when you multiply straight across, you would get x squared plus x minus 6 over x plus 3 squared. But then you need to factor if possible. So you need to look here at the factors are there any factors of -6 that add to 1? And there are. So here next step is to factor that trinomial. So we get x plus 3 times x minus 2, because 3 times -2 is a -6, and 3 minus 2 is 1. On the bottom, you have the quantity x plus 3 squared. So again, you want to write it out twice. So x plus 3 times x plus 3. And so then now that you have this, your x plus 3 on the top can cancel out with one of the x plus 3's on the bottom. So your final answer, you're left with x minus 2 over x plus 3. So this whole thing is your answer. Okay, number 5. Again, you want to look and see, is this factorable? And on the top it is. X squared minus y squared. This is a difference of squares. So you'd be left with x minus y times x plus y. On the bottom, you say, are there any factors of 2 that add to 3? And there are. So you would have x plus 2y times x plus y. 2y times y would give you 2y squared. 2xy plus 1xy would give you 3xy. So it was factorable. So then again, we simplify what we can. This x plus y on the top cancels out with the x plus y on the bottom. So then you're left with x minus y over x plus 2y. All right. So right away here with number 6, I can tell right now that this k plus 1 and the k plus 1 on the bottom can cancel. So you can get rid of these two right away. So that leaves us with k squared minus 1 in the numerator and the quantity k plus 1 squared in the denominator. So what you want to do with number 6 is factor it. So k squared minus 1 is a difference of squares. So it's going to factor into k plus 1 times k minus 1. In the denominator, you have the quantity k plus 1 squared. So we're going to write it out twice, k plus 1 times k plus 1. And then the k plus 1 in the numerator can cancel out with k plus 1 in the denominator. So then your answer, you're left with k minus 1 over k plus 1. All right. Okay, so for number 7, again, you want to make this negative exponent positive. So remember, you're going to take the reciprocal, so it's going to go to the denominator. So in the numerator, you would have the quantity x to the 4th minus 5x cubed plus 6x squared all over the quantity 9x minus x cubed. Okay. So when you factor, you can't factor or do anything until the highest exponent comes first, until this is in standard form. And right now this bottom one isn't in standard form. But we can do this all at once. So you can rewrite it. You can rewrite the top as, just leave the top alone, the numerator, x to the 4th minus 5x cubed plus 6x squared. And in the denominator, you want to go ahead and rewrite this in standard form with the highest exponent first. So we have a negative x cubed plus 9x in the denominator. All right, so then we want to simplify what we can. So what we want to simplify in the top is we want to factor out the GCF. And the GCF in the numerator is x squared. So when you factor out that x squared, you're left with x squared minus 5x plus 6. In the denominator, you need to factor out the GCF, but there's also a rule that this first term can never be negative. So we also want to factor out the negative. So the greatest common factor here is going to be a negative x. So when I factor that out, I'm left with x squared minus 9. So then you want to go ahead and see if these are factorable. Well, are there any factors of 6 that add to negative 5? Well, there are. So I'm going to rewrite this. So x squared, so x minus 3, x plus 2. So those would, I'm sorry, x minus 3, x minus 2. x minus 2, because we have to add to a negative 5 but multiply to a positive 6. And in the denominator, we have negative x, and then x squared minus 9 is the difference of squares. So I can factor that into x minus 3, x plus 3. All right, so now I want to reduce what I can. The x minus 3 in the numerator and the x minus 3 in the denominator can cancel. Now, also here, you have an x squared on top and a negative x on the bottom. So these can also reduce. You can reduce this to x to the first, and this x is going to cancel, but you have to be careful because there's this implied 1 here. So there's really a 1 between negative 1 times x. So when you write your final answer, it's going to look like this. X parentheses x minus 2 over negative parentheses x plus 3. Okay, so this whole thing is your answer. You cannot forget about this negative that was in front of that x there. Okay, let's go ahead and take a look at this next one here. Remember, we always want to make sure everything is fully simplified. So what we have here, x to the 4th minus y to the 4th, this is a difference of squares. So this is going to factor into x squared minus y squared over x squared plus y squared. On the bottom, you want to see, are there any factors of 1 that would add to a negative 2 but multiply to a 1? So there are. So we're going to get x squared minus y squared times x squared minus y squared. So you can see you have a negative x squared y, and a negative x squared y gives you a negative 2x squared y, and then negative y squared times a negative y squared will give you the positive 4, or positive y to the 4th. So at this point, again, you can cross out the x squared minus y squared on the top with the x squared minus y squared on the bottom. Now, you always want to make sure this is fully factored. So on the top, x squared plus y squared, that can't be factored anymore. So we're just going to rewrite it in the numerator, x squared plus y squared. But the denominator can be factored one more step. You can go ahead and factor this. This is a difference of squares into x plus y times x minus y. So again, you always want to make sure it's fully factored or fully simplified. All right, number 9 is a little bit different because if you notice now there are 4 terms. So what you want to do is you want to group the terms. You want to see if you can group the 2 of them together and see if there's anything that you can factor out. So you want to group the first 2 together, and then we're going to group the second 2 together and see if they have a GCF. So if you look here at x to the 4th plus x cubed y, they do have a GCF that I can factor out there. The GCF is an x to the 3rd. So when I factor that x to the 3rd out, I'm left with x plus y. On this right-hand side, in the second set of parentheses, they do also have a GCF. It's a negative y to the 3rd. So I'm going to factor out that negative y to the 3rd. So when I do that, I'm left with x plus y. Okay, so now hopefully this is looking a little bit familiar. So it should look like what we did as factor by grouping, right? So I'm just going to draw the denominator under here, x to the 4th minus y to the 4th. So at this point here, like I said, it should look familiar. You have x plus y in parentheses and x plus y in parentheses. That means it goes back to what we did last chapter when we did factor by grouping. You have, so you can rewrite this as x cubed. Remember, you put the GCFs in one parentheses, x cubed minus y cubed. And then since you have both of these, x plus y and x plus y, you can bring that down and put x plus y. You only have to bring one of them down. All right, now if you notice the bottom, x to the 4th minus y to the 4th, this is factorable because it's a difference of squares. So this can factor into x squared plus y squared over x squared minus y squared. So now we need to check, is everything factored, fully factored? Well, what we have here on the top, x cubed minus y cubed, this can be factored again because this is a difference of cubes. So you want to go ahead and factor that. So we have x minus y. Remember, you square the first term, x squared. You multiply x times y and switch the sign, so plus xy. And you square the last term, so y squared. But then we had this original x plus y too. We have to bring that as part of your numerator. All right, in the denominator, x squared plus y squared can't be factored, so I'm going to just bring that down. But x squared minus y squared can be factored. This is a difference of squares. So we get x minus y, x plus y. So now we see what can cancel. Well, this x plus y on top can cancel out with the x plus y on the bottom. X minus y on top can cancel out with x minus y on the bottom. So you're left with, in your final answer, x squared plus xy plus y squared over the quantity x squared plus y squared. So this is your final answer. So again, you always want to make sure everything is fully factored. All right, so let's go ahead and look at number 10. So in number 10, you want to, again, start by grouping it. So we have these first two terms and these second two terms. Same thing on the bottom. You want to group these first two and these second two. All right, so on the top, the GCF is t squared. When you factor that out, you're left with t plus 4. On the right-hand side, the GCF is a negative 1. So you're left with t plus 4. On the bottom, when you factor out the GCF, it's t squared. So you're left with t minus 1. And the only thing in the second set of parentheses that they have in common is a positive 1. So you're left with t minus 1. All right, so now at this point, remember, you're going to write the GCFs that you factored out in one parentheses. So in the numerator, you have t squared minus 1. Since these two are exactly the same, you bring down one of the parentheses, t plus 4. In the bottom, again, you write the GCFs in one parentheses. So we have t squared plus 1. And we bring down one of these, t minus 1. All right, so now, again, you have to look and see, is everything fully factored? Well, t squared minus 1 can be factored again. It's a difference of squares. So this is going to factor into t minus 1, t plus 1. You also have this t plus 4. In the denominator, you want to see, is there anything you can factor? T squared plus 1 cannot factor, but you also have this t minus 1. All right, so then you want to look and say, okay, what can I simplify? Well, t plus 1 in the numerator and t plus 1 in the denominator can cancel out. So those are the only things that can cancel. So your final answer is t plus 1 times t plus 4 over t squared plus 1. So all of this is your final answer. All right, thank you for watching the video.